Greetings, Kerbonauts! This is Kerbal Space Program. I'm Bob Fitch, and this is episode number 3 of Project Ares. In the last episode, we left off with our second launch of the new install here. Even though I really haven't completed the coverage of the first launch, I will eventually get back to the final details about that one later, I swear. But for now, let's look at the second launch a little bit more. Well, we've hit a snag, so we're not going to get to finish that one either. Let me explain. First of all, you remember the launch site was in Mogadishu, Somalia? That's because the Earth Union wanted an equatorial launch site, and Mogadishu was one of 3 proposals that made it to the final round of evaluations. The other 2 options were in Brazil and the Philippines. The Philippines were ruled out because it was far from the initial host nation sites in the Earth Union Space Agency, and because it was deemed too difficult to reach with all the needed construction materials and all that compared to the other 2 sites. And the Brazil launch site was ruled out due to weather, too rainy, too often. So, Mogadishu was the best choice, according to USA, and thus construction of the first VAB and launch pad was started there. Now, during tests of the communications network, which in my case of course means remote tech, but let's pretend it's real Earth communications. During tests, it was discovered that launches would go beyond the horizon before reaching orbit, so a secondary communications link was established up the coast at a place called Hobyo, still in Somalia. That little distance was enough to get a better angle, and so from there we get our real first remote tech link for our launches. Now while we're looking here, notice there are some colored dots for sites. I have selected these colors based on what the sites are. They'll all be different things. Yellow will represent launch sites, and I may have more later, but right now we just have one right here. This is our Mogadishu. Then blue is a remote tech communications dish that will be a longer range and have one of our main links. And we'll put more of those around the world over time as well, but for right now we just have one. Then teal spots are important world sites that are more for show than they are for communications, but I do have small remote tech dishes in those as well. There are 2 of those. One is in Rotterdam as the seat of the new Earth Union, which is kind of like the United Nations from New York City, though now that will never be created. The real United Nations was founded in 1945, just like our Earth Union, so essentially this new Earth Union government is the United Nations, and therefore the UN won't ever exist. But due to the contact with the Kerbals, they had much more incentive to create an actual government rather than just founding some sort of governing body that, who knows what the UN does, I don't know. Anyway, we have another teal site here at San Francisco to represent the main site of the Earth Union Space Agency, which in the real world, for the United States at least, it would have eventually been Houston. You know, Houston, we have a problem. But in this alternate reality, it was selected to be at San Francisco, and if you think you know why, go ahead and post that in my comments. I'll bet a lot of you take pretty good guesses at that one. For those of you who don't figure it out, I'll let you know next week. Earlier, I had said we hit a snag with launch number 2. Well, apparently the Hobyo remote tech link is not good enough for my new launch. And to explain that, I probably need to head into the VAB for just a moment. The last time that we were in the VAB, I had been showing you the setup for Phoenix 1. We had our satellite here atop a relatively simplistic rocket, a core sustainer with 3 boosters around the outside. I had not shown what the 3 boosters looked like yet, so what we had there is these nose cones that have separators right here and here that are built into the nose cone. Those are pretty cool. They help push those away. Also, if we take the nose cones away, you can see I'm using the same system as I did for the core. There are interstages and tanks that look like actual individual fuel tanks, as well as each of them containing only what it needs. In this case, 17,000 liquid oxygen. And then we work our way down and we have ourselves an interstage, and down here we have some ethanol 90 in another tank. We have separators, an interstage, the HTP in a tank there. Around the outside, remember I had gone over the engines? Well, these are listed as Booster 1 because this is the first launch. Phoenix 1 had Booster 1 stats. And so you're going to see here the 293 ISP, for example, with a vacuum thrust of 763. Well, the Phoenix 2, we've upgraded our technology a little. So if I switch over to Booster 2, you're going to see the slightly higher technology of Booster 2. It's gone to a 294 ISP and a 916 for vacuum thrust. So greatly improving the vacuum thrust over the previous version. And that's pretty consistent with what happened in real life. Over time, they really improved the thrust of the engines. One interesting bug I've found along the way is notice this EUSA is backward over here, but correct over here. Well, I found out that if I take this wing piece, as I move it side to side, sometimes it shows up correctly, and other times as I move it, it shows up backward. And I can get it on the edge here where it flips back and forth, even though the orientation doesn't seem to be doing much. It's like the wing is flipping around and going inside out or something, because also notice there's a little circle right here, and then when I move it just a little bit to the side, the circle changes positions. If we look at this other side of it, you can see that that swaps positions there as well. The circle's at the top, and then you move it a little, and the circle's at the bottom. So in order to get the symmetry I want, I have no choice but to let it be backward on a couple of the fins, but correctly oriented on the other fins. Kind of strange. Anyway, that finishes looking at Phoenix 1. Now let's look at the difference between Phoenix 1 and Phoenix 2. And here you're going to see why I had a problem. So this is entirely the same as Phoenix 1 all the way up until we get to the second stage. We had a much heavier payload in this case, and so the second stage needed to be added in order to get higher up, and that caused the launch itself to take longer, and the longer launch meant that we're going over the horizon and the remote tech link at Hobio doesn't work anymore. Okay, so looking at the payload, you can see we have a much heavier payload up here, and so this launch from the bottom down was all identical to what it had been for Phoenix 1. But then there's this interstage that's a lot like some early Soviet launches where they have that gap so that the engines can be started while we're still lifting off. Well, the same thing is going to be at work here. We have some gimbal engines up in there and a main engine here. This is a whole new type of engine. It's the Cyclops upper stage engine. And later I will explain how we got the Cyclops engine, but the short version of the story is that Sergei Korolev is working on the lower stages and the boosters, and Werner von Braun is working on upper stages, and so he came up with the name for the Cyclops upper stage and worked on all of the stats and everything that goes on up in here. So you're going to see that this is a combination of liquid oxygen in one tank, and ethanol 90 in the other, just like the lower, because those are the fuels we're working on. And we also have HTP to power the pumps that are in this engine because they're sharing technology. We got our T-TEB to get it started because it can only start once. There are some retro rockets built into this stage that has the HTP. It's using a solid fuel called PSPC, which is a period fuel of that time. And then later we will cover what the payload is actually composed of, but for now, let's get back out and look at the launch. Not the launch we were watching, though. I now have Phoenix 2, a second version of it, back out on the tank. You can see we have our nice little cool rockets effect, working on the engines down there, keeping them cool, because this is liquid oxygen in our tank here. Anyway, we have to launch a second copy of this. Oh, wait, let's turn on the lights. I just noticed they're not on, and you gotta have more lights. If we go out to the map, you can see now we have another remote tech link right here. Because what was happening was I would launch and the Phoenix 2 would get up a little ways and then it would go over the horizon because it's a much heavier launch and was taking longer to go. And so Hobyo wasn't good enough. So another remote tech link, and that's why it's blue, was set up over here at the tip of India in a town called Kanyakumari. That will hopefully be able to pick up where we need the, where the other one is going to give up. And so I am going to just get myself down here, back to the pad, get these engines started. Notice it doesn't matter where I set the throttle as long as I have it anywhere in here, because again, these things, once they start, they ramp up in their speed, their power, their thrust, and then they take off and go at maximum rate. So notice right now it says that we are very stable, 1 ignition. I'm going to leave this up so that you can see how this works, but you'll watch the fuel flow will ramp up from 0 up to a higher rate. The thrust will ramp up, the kilonewtons thrust here will ramp up, and then after I've activated the engines and let them get up to speed, then I can decouple. If I do it early, they won't be ready and the whole thing will drop back down on the pad. So here we go. I will show it to you. We'll get our T-Teb here burned off and staging. There we go. So now it's building up thrust and we're at 100%, so I can release and off we go. So you can see that's another realistic thing that I have going on here. So now if we look back at that first attempt at Phoenix 2, it makes more sense. Notice it's way past the apoapsis. It's heading back down to the ocean because we lost contact with it as we went further away. But if we skip back to the future, now we're in the middle of launching Phoenix 2, and you can see there's that new remote tech site at the tip of India, and that is going to allow us to stay in communication. Speaking of communications, I'm not using the normal remote tech rules. First of all, I'm not using the signal delay because the game just isn't fun anymore when you have to wait realistic times between sending and receiving messages. Second, the default way remote tech works is you have to have 2 communication devices that are capable of reaching each other. Now before we go any further with that description, let me just quickly show you. You can see here my Hobyo remote link connection that's going up to the satellite right there. Anyway, about those ranges, let's say for example that you have a satellite that's 1,000,000 kilometers from Earth. Regardless of what kind of ground station you have, the satellite would normally need a dish that can reach 1,000,000 kilometers in order to communicate home. And that can lead to having some huge and unrealistic dishes on your satellites as you get further away. So instead, I'm using a special remote tech option called additive mode, also known as root mode. Using this option, the actual range of a link is the smaller range of the 2 devices plus a bonus portion of the larger device, the larger range. The bonus for the larger one is the square root of the 2 ranges multiplied together. So here's an example. Let's say that I have an antenna that can reach 100 kilometers, because I do on the satellite. And let's say the initial ground station I'm using has a 5,000 kilometer range, because it does. In normal remote tech, the range would be 100 kilometers because that's the smallest of my 2 devices, the antenna that's on the satellite. Using additive mode, the range is actually the 100 kilometers plus a bonus of the square root of 100 kilometers times 5,000 kilometers because that's the 2 devices. And that comes out to about 707 kilometers. So you add those 2 together and the true range of that link is 807 kilometers. This will allow me to place huge ground stations on Earth, which will be very realistic, and so that later on I can communicate with small and realistically sized dishes that are on satellites that are way far away, going out to outer planets and leaving the solar system and all that good stuff. Since we're in the middle of remote tech discussions, it probably makes sense to finish off the topic. And I'll do that right after we decouple that lower stage, let the second stage head on up. Remember, we need to settle the propellants, and right now we have sort of an artificial gravity from the thrust of that lower stage. So by activating the engines early, when we decouple the lower stage, the upper stage just keeps going and everything's fine because the engines were started. They ramp up from a low thrust to a high thrust, just like my ground engines do, but it's okay because we're up and way up above the atmosphere now. Alright, now let's finish off remote tech. Remember I made a list last episode of things I wanted to cover right away? There will be more, but this was my starting list. For number 13, remote tech upgrades, I will make changes over time to simulate advancing technology. I'll add new antennas and dishes with options of longer and longer ranges and maybe better performance as far as their electrical consumption, for example. For number 14, about the ground site rules, I will slowly add more and more ground site dishes as well that will have longer and longer ranges. For example, right now my first sites, represented by the blue dots, have a range of 5,000 kilometers. Well, perhaps every 2 years of game time, I will double the allowed max range and add another site or two on the ground somewhere around the globe. And of course, I will tell you each time I do these so that I can keep you up to date. The second ground site in India isn't strong enough to keep constant contact during my whole liftoff. Notice the satellite says it's out of communication range right now. The engines keep going, but I can't steer it until it flies over India and I regain control. By then the tanks are almost dry and we can shut down and then decouple the payload. There are no deorbit burns necessary for these launches because I'll be pretending there's atmospheric drag even beyond the point that normal KSP would say there is, and I'll assume that in a few months the stage will re-enter naturally and burn up, and that's consistent with a realistic atmosphere. There's a mod that can handle that automatic decay and deorbit of satellites, but I don't want to use it because I don't need to. It's the same reason I don't use signal delay on remote tech. It might be realistic, but I don't want to be forced to play that way when it's not fun. For the same reason, I will just deorbit my own satellites when I know that they should, and let them stay in orbit when I know that they would. I don't need a mod to do that automatically in this case. Okay, there we go. Phoenix 1 and Phoenix 2 are both in orbit. Phoenix 1 only had a transmitter, but Phoenix 2 has a magnetometer and an ion trap. You saw me open those already. We'll use those to test the space that's all around Earth for as many orbits as we can before this thing gets sucked back down into the atmosphere. Now remember, in real history at this point, there was no knowledge of the Van Allen radiation belts. Phoenix 2 will now be able to detect those, and they'll still be called the Van Allen belts because he's the lead scientist in my world who is spearheading that experiment for this launch. Another difference with the Phoenix 2 is the solar panels. They're very low tech and flat on the surface of the satellite's frame, because at this point Earth doesn't have the advanced technology to do extendable panels or articulating panels. We'll develop those technologies soon though. This is Phoenix 2 in the VAB. You can see we have our ion trap there, magnetometer there, and communications right there. There's solar panels all around the outside, so it gets light from every angle. And then here we have our link for the antenna, the battery, and these extra CPUs on the side are another house rule I'm using. These are science instrument computers, or science processors. They generate a custom resource that I created for myself called Science CPU. That resource gets consumed by experiments. So in other words, in order to have more and more experiments, I need to add more and more science CPU, and so I need either more of these parts or bigger ones. In this case, these were good enough for each one of these to run one of the instruments. So one was the ion trap, and one was the magnetometer.
Yes, I've verified your findings. The rift continues to draw more and more power.
And it's rising geometrically. I know we'll lose contact with Earth, but let's seal it for now.
And then we can figure out what to do next. Yes, I agree.
We've come to the end again. It won't be long before we're colonizing low Earth orbit, and then the Moon, and then Mars. But if you have ideas for other things you'd like to see in an alternate Earth timeline after creating a new world government, feel free to leave it in my comments, and maybe one day I'll have time to incorporate some of the suggestions. You could also suggest launches you'd like to see one day, whether real or fictional. Maybe stuff that could have happened if the world had been united instead of divided by a Cold War and a moon race. But until then, I will see you later, Kerbonauts.